Hello everyone. Now in this lecture we will know about the how to find the candidate key, right, with a given relation. Candidate key may be defined as set of minimum attributes that can identify each tuple uniquely in the given relation is called the candidate key. Set of minimum attribute or minimal attribute or attributes. For example, that one is simply we have a table contains four column or the four attributes, and we can say that this one is A, B, C and D. Now this is the roll number, then name, then mobile number and the address. Now set of minimal attribute that can identify each tuple uniquely. If we consider that roll number 1, with the help of roll number 1 we can identify the unique record, right, as this row. Then minimum attribute that can be identify each tuple, that means roll number is a candidate key, right, in this scenario. Or the set of attributes, it may be the roll number and the name, combination of roll number and name, it may be the candidate key, because of which one is identify the unique tuple, unique row. Set of minimal attribute that can identify each tuple uniquely in the given relation is called the candidate key, or the minimal super key is called a candidate key. After the find out the candidate key or what is exact the candidate key, then we will know about the super key also. Now for a given relation, it is possible to have multiple candidate keys. Like with a given relation, it may be have a multiple candidate keys, like the roll number, or it may be a mobile number, or it may be a combination of roll number and the name, or name and mobile number, right, or name or address. These are the possible have the multiple candidate keys, which one is uniquely find out the record. There exists no general formula to find the total number of candidate key of a given relation. There is no any theory or the formula to find out the exact candidate key count. Then simple example, that is student table, roll number, name, sex, age, address, class and section. Given below are the example of a candidate key. Write the class, section and roll. Class, section and roll. With the help of we can find out the unique row, or it may be with the help of name and address we can find out the unique tuple or the unique row. This is simply the example of some candidate keys. These are candidate key because each set consists of a minimal attribute required to identify the each student uniquely, right. That is the minimal attribute which one is find out the unique row. That is the definition of candidate key. Finding the candidate key, then with the we can determine the candidate key of a given relation using the following step. If in the particular we have a relation, then we can find out the candidate key. These are the steps how to find out the key. Step 1, determine all essential attribute of the given relation. Then we need to know about essential attributes means what. Then essential attribute are those attributes which are not present on a right hand side of any functional dependency. If we take a simple example of a functional dependency, right, relation, that one is A, B and C, and we have a functional dependency that A has a B, A determines a B and the B determines a C, right. Then what exact the essential attributes are, which are not present on a right hand side of a functional dependency, which is not present on right hand side. This one is the right hand side, right, this one is the left hand side. Then B and C is available at the right hand side. That's why B and C is not essential attribute. Then what's the remaining? A is the essential attribute with a given example. Okay, that is simply the essential attribute. Essential attributes are always a part of every candidate key. Then if we find out the A as an essential attribute, then we can say that the essential attribute is a part of every candidate key. Then this is because they cannot be determined by the other attributes. That is simply the explanation about the essential attribute. Now we will go with a simple example. That one is example contains a relation. That one is a relation A B C D E F, and then functional dependency with the A as determines B, or C determines D, then D determines E. Now that one is which are the essential attributes? Then a relation contains A, B, C, D, E, F. Then the condition says that the attribute which one is not present at the right side, not present on the right hand side, that one is the essential. Then B is not essential, D is not essential, E is not essential, B is not essential, D is not, E is not. Then pending A, C, F, A, C, F, right? Then we can say that A, C and F are the essential attribute. A, C, F are the essential attribute. Now the second step, the remaining attributes of the relation are non-essential attribute. Okay, remaining attributes are the non-essential. Then remainings are, that one is B, D and E, right? These are the non-essential. Now because they can be determined by using essential attribute. Why that one is a non-essential? Because non-essential because of that one is determined using the essential attribute. Now following two cases are possible. This one is simply the way to find out the essential attribute. Now these are the two cases is generated. If all essential attributes together can determine the all remaining non-essential attribute, means with the help of this essential attribute we can determine the all the relational attributes. Then all remaining non-essential attribute means all this essential attribute determines all non-essential attributes. Then the combination of essential attribute is the candidate key. It is the only possible candidate key. Then what is the combination of these is the candidate key. If with the help of this essential we can determine a non-essential, right? That one is simply the condition or the case one. If all the essential attributes togetherly or combinedly determines the remaining non-essential attribute, then this one is the condition. That is the combination of essential attribute is the candidate keys. Now case 2, if all essential attribute together cannot determine, means the reverse of this, then what will be the situation? The set of essential attribute and the some non-essential attribute will be the candidate key. Means here only the essential attribute or the combination of essential attributes will be the key, candidate key. Here essential or non-essential, the combination of essential and non-essential attributes will be the candidate key. In this case multiple candidate keys are possible. To find the candidate key we check different combination of essential and non-essential attributes. Now we will go with the practical example. That one is based on case 1. Then this is the relation. This one is the following dependencies. Now which of the following is a key for R? It may be an exam content this type of question. It gives the relation and the functional dependency and it gives the option which one is the correct one. Following is the key for the R. Now we need to find out the candidate key, also determine the total number of candidate key and super key, and we want to find out the key for this relation with the total number of candidate keys and super keys. Means with the help of this example, how many candidate keys are present and which one is present in this option, and how many super keys are present for this relation. Now solution, we will find the candidate key of given relation in the following steps. Step 1, determine all essential attributes. We need to find out the all essential attribute first, then the relation, that one is we will find out essential attribute, that one is a relation contains A, B, C, D, E, F. Now the which one is not which is the present for the right hand side, F. F is not essential, A is not essential, D is not essential, then B is not essential. Then essential attributes C and E. C and E are the essential attributes, right? Then the essential attribute of the relation are C and E. So attributes C and E will define the part of every candidate key. Okay, C and E is the part of every candidate key now. Then steps 2, now we'll check if essential attribute together can determine all remaining non-essential attributes. Can the essential attributes determine the remaining non-essential attributes? Then we need to find out the closure of the CE. Closure of the CE. Then closure of CE. Then we already in a previous lecture we already know about how to check the closure of given attribute set. Now C is itself present in the closure of the CE. Now if we check the C represent the F, then F is present, then CEF, then C, we will go with the relation. C represent the F, then E represent the A, E is present, that's why A is also available. Then EC represent the D, that's why D is also a part. Then A is represent the B, A is again the A is available, then B. Then this one is simply the closure of the CE. Then A, B, C, D, E, F means the essential attribute represent the determines all the non-essential attributes. Non-essential attributes are the A, B, D and F. That's why we can say that the particular, to check whether the file closure of CE and that closure determines all remaining non-essential attribute true, then if the determines all non-essential attribute, then we can say that we conclude CE can determine all the attribute of the given relation, right? Then CE is the only possible candidate key in the given example. Then what is the answer? Here CEEC, B is the answer, 2 is the B is the answer, right? To find out the candidate key for this relation, then EC or CE is the answer. Now only what will be the count of a candidate key? In the case 1, if it determines all the non-essential attribute, that the key is only a candidate key. Means total number of candidate key is only one candidate key, that is the CE. When the only one candidate key is present, when the essential attribute determines all the non-essential attribute, then in that scenario only one candidate key is possible, that is the CE. Right here in this example, C is the only a possible candidate key. Now the total number of super keys, then there are two essential attributes C and E. That one is comes under the each and every super key. Now remaining 4 attributes are non-essential attribute. Essential attribute will definitely present in every key, that's why this one is a mandatory, C and E. Non-essential attribute may or may not be taken in every super key. That's why CE is the mandatory, and remaining 4 attributes run with the combination of that two choices. That one is calculated with the this formula. If the non-essential attributes are the 4, then you need to adjust to 4 times 2 into 2 into 2 into 2, and that answers the 16, and it represents the total 16 super keys are possible. CE here is a mandatory to each and under the each and every super key. Means in this example, one candidate key and the 16 one candidate key and 16 super key is the possible, right? This is simply the way to find out the total count of a candidate key and super key in the single scenario, in the case 1, right? Now in next lecture we will know about the case 2 and how to find out the candidate key, and how to find out the count of candidate key and the count of super key. Okay, this one is simply the explanation about to the find out the candidate key in the particular given relation and with the help of the functional dependency. Thank you.